Hi everyone, thank you because joining us today's webinar. Today's session is Salford Predictive Modeler, how to build a classification model. Okay, I'm Nusrawati. I'm the technical support specialist at Busy System. Busy System are independent local representation for Minitab product and training for Malaysia, Singapore and Batam, Indonesia. Okay, Salford Predictive Modeler is separated software from our flagship product, which is Minitab statistical software, but it is one of the Minitab products. So this Salford Predictive Modeler is separated from the Minitab statistical software, but the one is one of another product by Minitab. Okay, before we get started, there are a few housekeeping items to take note. If you have any question during presentation, please type them into the question box in your control panel. You may send anytime throughout the presentation, but I will address them during Q&A session at the end of webinar. Okay. Kindly ensure that you have connected to the audio via your computer speaker. Okay, for your information, this webinar will be recorded and therefore it will be set as listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visits.com, or you may subscribe to our YouTube channel, Minitab Malaysia and Singapore. Okay, so now most of us talk about big data. One of the area in the big data is machine learning. For us in Minitab, we have another product we call Salford Predictive Modeler as a machine learning software. Okay, the major analysis for SPM is decision tree model. One of the mean of the SPM model is a classification and regression tree, or we call it CART. Okay, and then after that, to learn more about this software and this method, okay, we using the binary cases. And if we have a time, we show how to run the multi-cases using the SPM. And then for sure, every software have their own features. So for the SPM, basically we have features like automate, where we do experimental or some tuning parameter for all models before we choose the best model to do the prediction. Okay, so this our agenda. Today we go what is the machine learning and what is the Salford Predictive Modeler, SPM, and then we go for the classification and regression tree, and then we go for the features inside the SPM. Okay. Okay, so we go for the first, what is the machine learning? So machine learning basically is a subset of artificial intelligence, or we call it AI. So in terms of equation, machine learning can describe as a modern statistic plus with the computer sciences. So machine learning algorithm use competition method to learn information directly from the data without relying on a predetermined equation to model and to make a prediction and decision, which is machine learning is learn some information from the data, okay, not relying any assumption. Okay, so basically in machine learning concept, we split our data set into the training set and test set. So training, or some others researcher calling one is a learned data set, is to create the model. and then test data is to use to assess the model performance. Okay, so typically, and then most of the researcher split the data set into training and then testing by 80% training and then 20% be other testing data set. Okay, and then others splitting of the data set. Maybe we can using the cross validation. In cross validation, we have many types. One of them is K for cross validation. Okay, so basically in the cross validation, we split the data into the K subset of folds, and then after that we fit the model using fold except one, and then after that we compute the error using the held out or test fold, and then we repeat K times holding out each for one, and then after that we select model using summary statistic based on the test error. So basically, for example, okay, we have a 100 data set. Okay, after that we divide 100 data set into the 10k. Okay, into the 10k, 1 until the 10. Okay, and then we take one portion, we are the test data set, and the rest are the training set. Instead, we want to create the model. After that, we go for the next time. We take the another one, okay, another one, which is now is a k equal to 2. We are testing data set, and the rest are the 9 can be other training set for the second iteration. So we need to go for the 10 iteration, and after that we calculate the average of the 10, so you can get the cross validation, or we call it K full cross validation. So in this example, I just choose with the whether we split by 80 training set, 20 testing data set, or you can using for the cross validation by the K full cross validation. So for this case, I just choose K equal to 10. Okay. Okay. Sorry. Okay. Okay. Sorry, I go back to this one. So now you can see our screen or not? Our slide or not? Yes. Okay, so I starting with the first slide. Okay, sorry. Not where here, this one. This one is the first slide. Okay, this one is second slide. Okay, this one is a third slide. So you can see our okay, let's see. It's moving. Okay, sorry. I'm just trying. Okay. Stay at the first slide. Okay, sorry. Okay, so now you can use my screen right now running. Okay, thank you. So I will do again. Okay, I think I just go with the this one first. Okay, so basically, it's a machine learning is a subset of artificial intelligence, or we call it AI. So machine learning equal to modern statistics plus with the computer sciences. Okay, so machine learning algorithm use computation method to learn information directly into the data without relying on a predetermined equation to model and then make the prediction and decision. Okay. Okay, so the main concept of the machine learning is we need to split our data set into the training set and the test set. So what from the training set, basically we want to create the model, and then the test set is we want to assess our model performance or our accuracy of the model. So basically many methods into splitting our data set. One of them is by, we assume that 80% from the data set be the training data set, and then another 20% maybe testing data set. And then others method, we call it cross-validation, okay, or we call it K-fold cross-validation. So for the K cross-validation, basically we have a 100 data set, okay, 100 data set. And then from the 100 data set, we divide by 10. So means that every group, we have a 10 data set, okay, until from 1 until to 10K. Okay, so means that 10 group. So first step, maybe we take one, okay, be the testing data set, and the rest is K1 up to K9 be the training data set. Okay, so the first interaction. Second interaction, maybe we take the K equal to 9, okay, 9 be the testing data set. So means that the rest is a training data set. This one is second iteration. So you need go for the anti 10 kill. And then after that, you take it the average. So this one is the how cross validation its function. Okay, so for today, I just go through with the two type, which is splitting 80% to 20%, and then cross validation. Okay, so in the machine learning model, we have a two type, which is we call it unsupervised and supervised. But for today cases, we just focus on the supervised, go with the classification. Okay, but what is the unsupervised? Unsupervised basically is a technique doesn't have any outcome, which is we doesn't have any targeting, or we want to just only group our data set. For example, of unsupervised is define the customer segmentation, which is within a customer base, which is we want to classify with a name, gender, maybe age, location, and the status, married or not married. So this one is what we want just only group our data set. And then for the supervised, which is that we have all our target, and then we have a multiple predictor. So in the target, as we know, target is a Y, okay, Y variables, and then Y variables can be classification or can be a regression. So maybe our target is, let's say, accept reject. So this one is, we call it is a binary classification, or yes or no binary classification. Or maybe we have a color, let's say green color, yellow color, red color, black color. So this one is, we call it multi-classification. But let's say your Y is a measurement, let's say it's a temperature, or 100 temperature, 37.6 temperature darjah Celsius. So this one is we call it the regression. For this case, for this today webinar, I'm just focused on the classification where why variable is the classification, whether it's a binary or multi classification. So for situation in manufacturing, let's say we have a accept, reject, go, no go, so the consider is a binary. So or let's say we have a type of failure of the defect. Okay, so this one is a classification. Okay. Okay, so for the supervised learning classification, maybe is we have a categorical response called qualitative variables or attribute variables. So this one is how they manipulate the wording for sometimes we using classification, sometimes we using categorical, sometimes we using qualitative. This one is only the wording but the same meaning. Okay, for example, we have a numeric, like say we have one is female, we have two is male, or we have a survey result. Let's say we have one is agree, two is nature, three of disagree, and then we have a tax. Let's say we have a payment method, a cash or credit. We have a machine setting, let's say low, medium, hard, and then we have product type, let's say wood, plastic, or metal, or we have a date or time, let's say we have Monday, Tuesday, Wednesday. Okay, or we have monthly of the year, we have January, February, March, and so on. Or we have a quarterly, quarter first, second, third, and the fourth quarter. Okay, so this one is all that kind of, we consider that is a classification clusters. Okay, so basically, Salford Predictive Modeler, SPM, is a machine learning software, but we were founded in 1983. Okay, but 2017, Minitab acquired the Salford system. Okay, and then SPM, Salford System Modeler, or SPM, is a reliable and robust because it was crafted and implemented by inventor of and the pioneer of the predictive analytic and machine learning. So they are Dr. Jerome Brightman, Dr. Liam Brightman, Dr. Richard Awesome, Dr. Charles Stone. Okay. So this one is the how broad and deep is SPM potential. Maybe you are from the manufacturing. Maybe you can use SPM to know about the manufacturing defect, or you want to do the preventive maintenance, or let's say you are from the finance services. Okay, so maybe you can go for the loan default or fraud prevention, or you are from the healthcare, maybe you want to know about the disease prevention, or you want to do the genetics researcher, or others industry, maybe you want to do insurance claims or environment. So SPM also potential if let's say you are from the sales department, you want to know about the customer churn, or you want to do the cross sell or upsell, or you are marketing, also you can using SPM. You want to know about the customer segmentation, or you want to do the marketing lift. So this one is the how you can use SPM in the real life. Okay, so this one is some organization using the SPM. So this is Bank of America, this and Lie, and then so on. So I think I go to the SPM first. Okay. So once you launch the SPM, okay, the interface looks like Minitab statistical software. For those we are familiar with the Minitab statistical software, but in SPM, we have a classical output content, content technical log producer by SPN engine, and then we have a left is a report to contain the right of for the text editor. Okay, so in SPN, basically you can call or you can import data into this SPN worksheet. So I try. So I have one case study here. So I just click open. Okay. So I will go to open file. Okay, where you set your data set. So you click that data set and you click open. So basically, many type of the data set as you can import into the SPN. For example, we have a JMP or your data set in the SAS, okay, or your data set in the SPSS. So basically, if your data set in Minitab, you can automatically import into this SPN. No need to transfer to the Excel, and then after that you calling back to the SPN. So for example, I have the Excel file, CSV file, and then I just click open. Okay, so once you you import your data set into the SPN, they pop up. We call it, this one is activity windows. In this activity windows, they provide you the information like how many records, means that how many data set you have, how many variables you have, and then what type of your variables, is character or numeric data. Okay, inside here also we have let's say you want to view the data first, so you can go for the go to the view data. Okay, so you can go back to the, if let's say you want to go for the activity window, so you can go back to the open activity window. Okay, so in this activity window, basically you can go for the view data, you can go for the discrete statistic, you can go for the graph. Okay, we can do for the correlation. You want to do the data preparation, you can go for the option, and then you can go for the score, which is if you want to do the prediction. Okay, I will show after this, and then we have the main here is we need to go to the model. Okay, but before I go further, I need to back to the our slide first. Okay, so this one is the how SPN works. So means that you need to import data into the SPN, whether in Excel file or Minitab file. And then maybe the first step, if let's say you want to do data analysis, we need to start with the discrete statistic. Let's say you want to know about the mean, want to know about the missing value. So you need to go for the summary statistic, or you want to do some graphical. Okay, you want to do the correlation, because this software is most for the modeling method. So the first thing is we need to go for the correlation. After you do this summary statistic, okay, we go for the model, where we want to create the model. So inside the SPN, inside the SPN, we have a model. Let's say CAT is a classification and regression tree. We have a tree-net model, we have the random forest model, we have the Mars model, we have a role learner model, we have SI, we have a general path seekers, GPS. So the main basic model for the SPN is a decision model. Okay, we have a splitting our data set. We have a decision, so we need to starting with a cut model. Okay, and then after we get the best model from this one, whether it's a cut or tree-net or random forest or Mars, so you can go for the prediction, or you want to do the scoring. So this one is how SPN works. So you need to bring the data into the SPN, you do the some statistic, after that you create the model, after that you do the prediction. Okay, so this one is a 4 major principal engine in the SPM. Okay, So we start with the cut. Cut means that the classification and regression tree, which is this one is by Brightman, and Austin and Stone. Okay, basic one, cut is the decision tree algorithm that works by creating a set of yes or no that split the response into the partition based on the predictor setting. Then cut basically is easy to use, easy to interpret. And then we have another one is a mark. For those are familiar with the regression, in the regression we have some like equation y equal to mx plus c is the basic one. So whether you're using least square method or Haber method, so whatever. But in the SPM, we have the sim-slot regression, okay, but we have a model by piecing together a series of straight line which each allow in own slope. Ideal for those are prefer result in a form similar to traditional regression. Okay, we capture the non-linearity and interaction. The basic one, easy to understand. Mark is something like combination of the linear regression. So we have one model, but model built from the combination of the simple linear regression. So that's why they can capture non-linearity and interaction. And then for the mask, they not provide, let's say, the simple equation like y equal to mc, but they using the basis model, basis function. Okay, it's like more complicated, but it's so nice if let's say you are from the regression background. Okay, and then we call it, this one is a random forest, and Trina is the something like innovation from the cut. From the basic one is the cut model, is we call it random forest. Random forest by Leo Brightman and Adele Cutler. Basic one, random forest is a collection of many kinds, okay, that are not influenced by each other. Okay, and then the best for the best situation to apply the random forest is handle the wide data set. Means that you have a lot of variables rather than number of observation. Okay, and then we have TreeNet by the Jerome Friedman. Okay, in the TreeNet, they using the gradient boosting algorithm. Okay, that sequence fit smaller cut and then use the error from the previous tree to create a new prediction and update the model, more flexible and powerful machine learning. So basically, if we do the cut, after that, if let's say you're not satisfied with the accuracy of the cut, you can go for the advanced, let's say, random forest or TreeNet models. But all these models applicable for both situation, whether classification or a regression. Okay, so it's something like more technically, but is simple to understand. We need to go for the cut first. Okay. Okay, so basically, cut is a classification and regression tree. So cut is a decision tree, okay, that works by creating a set of yes or no, okay, variable into partition based on the predictor setting. So in the cut, basically we have nodes, okay, and then we need to know some terminology inside the cut. The first one here is we call it root node. Means that the node at the top of the tree is we call it root node. And then if this one is we call it a tree split occurrer. So this is a splitting value. Inside how to decide which one is the the splitting value. So we have algorithm beside this, how to determine y negative 0.849. Okay, and then in here we call it, this one is the terminal node. Okay, terminal node means that a node has no sub branch, is a terminal node. So once this one is terminal node 2, terminal node 3. So inside there, you can see that this one is terminal node 1, this one is terminal node 2, this one is a terminal node 3. So inside these 3, we have a 5 nodes. Okay, so first, second, third, and so on. Okay, so we have 5 nodes. So inside the terminal node, we have the predictor value. Okay, so this one is the inside the predictor. Inside the terminal node, we have the predictor value in the cut 3 for classification. Is the class prediction or probability. So inside here. So if let's say you have regression, so inside the terminal node, you can get the predictor value. Okay, so this first splitting, second splitting. Okay, so you need, in your mind now, you need to know what is a root node, what is the splitting, tree splitting, and then what is the terminal node. So in the terminal node, what you can get value or something information is the predicted value inside the terminal node. Okay, so basically you want to use when you want to identify the most important predictor of response or target, or you want to do the discover combination of predictor or response or target, you want to visualize your finding. Okay, if let's say you are from the regression background, so regression we have equation, but now in the cut we have a visualization, instead we have a tree. We have a tree split. Okay, and then the advantages of the cut is we consider that it's non-parametric, and then therefore it's not rely any assumption. Okay, so cut is not significant impact by outliers. Cut is sophisticated method for dealing with the missing value. Cut is a relative simple for non-statistician to interpreting. Okay, so consider that if let's say you are from the regression background, cut is a non-parametric. So as you know, non-parametric doesn't have any assumption. Okay, so here I have one case study here. Okay, I have a paper manufacturer needs to use the current process data to determine which factor contribute to excessive variation in a pool bleaching process. The process is very non-stable. Okay, creating an acceptable defect rate. So they provide the data from the sensor collecting in the real time, and then the predictor is which is its production rate, discharge pH, constant, magnesium, okay, ambient conductivity. So all this one is a predictor, and then the target is we consider that classification. We consider that 0, 1. Instead 0 in control limit, 1 is the outside of control limit. Okay, so this one, this case, we consider that as a classification cases. I go back to the Salford directly, easy to see. So this one, okay, I use this case study where we want to, our target is the low here, refer to 0 and 1. So I go to the view data set. So this one is our data set. Okay, so low here is our target, and the rest here is the predictor. So inside the low, we have a 0 and 1. Okay, the value inside the low, 0 and 1. 0 means that inside the control. 1 is outside of the control. Okay, so from these cases, we want to do the modeling. Okay, we want to do the modeling because we want to do the prediction. Okay, so I go back to this activity windows. Okay, so we already view the data set. So if let's say you want to know about each predictor or about the target, so you go to stats. Okay, from here, let's say I just include all this one. So you go to up there and then select all the variables. Okay, in this one, they provide you fast tag, means tag no table, no quarter, it's a simple one, or you want to detail stack for the table. Okay, so after that you click OK. So means that I'm already choose all the variables here. So they provide the missing value, the mean, the maximum value, okay, the percentage. Let's say you want to go for the full, so go find the full. So they provide you location, variability. Okay, so it's more detailed. Okay, so I go back to that activity again. If let's say you want to do the, let's say, pie chart or histogram, okay, you can go to the graph. Okay, so for example, I want to choose all these variables, click all variables, and then you click to generate chart. Okay, so they provide all the chart. Inside this chart, you can editing your chart. Maybe you want to do the dot plot, okay, the pie chart or line or profile. Okay, you want to do number of pie, and you can editing inside the dialog box. Okay, I go back to this one again. Okay, so go to graph and then you check which one is want to know. Okay, click and then generate the chart. So they provide all the chart for you. Okay. I go back to the activity windows. The first, if let's say we go for the modeling side, we want to know about the correlation. Okay, for the case, I want all this one. Select all. Okay, so inside the correlation type, they not provide only Pearson but product moment, but they have a lot of type of correlation. I think we all always say that this one is a Pearson product memo, and I think you all guys always familiar with the Pearson product moments, or let's say you don't want, so you can go for the Spearmans or you can go for the skewness. So I just only for the Pearson, okay, of possible matrices, and you click OK. You click OK. Okay. So they provide all this one, the record, okay, the correlation stack. Okay, so this one is how they do it. But I think the most important here is go to the model. Okay, so where this one is how to build the model. Okay, how to build the analysis engine. Okay, so the first thing after you click the model setup, you see that this one is a red color. So means that in the red color, you need to decide the first thing is your target. For this case, low BR the first target. Okay, the rest is we assume that as a predictor. So go up there, select the predictor. For this case, is the classification. So you choose classification. Let's say your target is the regression, so you choose the regression. Okay, and then the main concept of the machine learning is a part testing part. Okay, for in SPN, they provide a lot of method for testing part, but most of them is depend on your number observation. Okay, for this case, I just wiggle around. I just choose for the fraction, which is 20% is the testing data, 80% the other training data set. Okay, or let's say suggested by for SPM model, let's say for the cut model, if let's say you have less than 3K, so you can using the cross validation. If let's say you have more than 3K observation, so you can choose fraction, or you can go for the test containing, or you can go for the separate learn or test data set. Okay, and then go back to the model. And then you choose here analysis engine. You just want to starting with the cut decision tree. Okay, this one is the basic setting. Okay, the basic setting, model, testing. The rest is the parameter. You can consider it. Okay, for example, it's a best tree. How we want to get the best tree? And this one is a method. So in the classification tree, in the deciding the splitting, so we have a method inside there. The most popular one is a Gini method. So that's why I just proceed with the default setting. It's a Gini method. So after that, go back to this one, you just click start. So now you get the tree. Okay, you get the tree. How we do? Go back to the models data. You setting the target. You assume the predictor. Okay, you need to declare your target is the classification or regression, and then you need to choose the analysis engine, and then if let's say you want to do some unique parameter, so you can go for the testing, choose the fraction, and then you click start. Okay, for this case, I already have the card here. So in this card 3, we have the ROC test. Okay, 0.99 is quite hard. And then the important, the predictor is we have 8 predictor. The best road node is we have a 9. And then this one is the our 3. Okay, inside 3, we have a terminal node. Okay, so in this SPM, basically we have a you can grow. Okay, let's say you don't want this one. Okay, we choose this one is optimum 3 because they provide the less number of relative costs. Okay, so the relative cost, like let's say like R squared, 0 until 1. 1 is the best, 0 is no relationship. So this one is a smaller value of relative cost is a good one. Sorry, smaller relative cost is the good terminal tree. But inside find the best tree, we have, let's say, minimum one standard error. Because if let's say you have a bigger number of tree, bigger of number terminal node, more complex your model. So maybe we need to choose the simplest model where the less number of the tree be the good model. Okay, so we have let's say for the optimum one here, because we have the smaller number of relative costs. Okay, and beside here, okay, beside this ROC curve, maybe you can go for the summary. Okay, from the summary, you not rely on only on the ROC. Maybe you want to rely on the misclassification. So how many percentage is correct, how many percentage is not correct way. Or we have another one is we call it confusing matrices. Okay, we have a specificity, we have a sensitivity. So it's a little bit technically, okay, but more researcher using misclassification or confusing matrices to assess the accuracy of the model. Okay, for example, if let's say you not familiar with the misclassification, maybe you can go for the ROC test. Okay, so from here we have a 9 terminal node. Okay, we have a 9 terminal node. So inside the terminal node, we want to know which one is the best predictor. So go to summary, go to the variables important. So from the variables important, actually its production rate is more important to the low target. Okay, so this one is a production tree. Next is the H2O2. So inside the production rate, what is the rows behind the production rate? So how you want to get the rows behind the production rate? So where? So you go back to this one, and then you go to the hotspot. Okay, find the best decision row. Okay, so click to 1 and click OK. Okay, so from here, go to stacked, choose the class count. So from here, you see that node 1 is the most important terminal node. Okay, so go back to the node 1. So it's this one, right click, U1 is the rows. Okay, so this one is a parameter setting for production rate is the less than or equal to 70.55. So this one is the setting for the production rate. Production rate is the important factor to the low target, which is the one is the outside of the control limit. So the parameter for the production rate is the 17 point less than or equal to 70.55. So this one is how the cut functioning to give the best decision to you. Okay, first thing we need to know what is the best predictor. Inside the predictor, we have a lot of value. So what is the best parameter for the parameter setting for the production rate? You go back to this one, right click, you choose the row besides here. So this one is the best parameter. So this one is how the cut functioning. Okay, I think it's a little bit confusing, but it's differences. The fundamental or the objective of this one is same with the regression, but the way the method inside that is different. So after we get the model, we want to know about the significant variable. So inside the SPM, we not call it the significant variable, but we call the variables important. Okay, variables important. So from the variables important, we want to do the parameter setting. So parameter setting we get from the rows inside the every terminal node. Okay, so basically color code also give you some information. Okay, so from here is the beta, is the red color, so it's a beta one lah. So for example here we want to know about the classification case with the one, so this one is 84. Okay, so this one is the 100, but the number of inside there only one. Okay, so you need to negotiate with the kind of the number cases also to consider the best rows. Okay, so from here also in the cut tree, basically we have we go back to the model setup, we have features, we call it the automate. Okay, automate. So inside automate, you can manipulate the, let's say we have a method here, Gini. So for this, for this case, we just proceed with the classification tree with the method Gini method. So let's say you want to know about the symmetry method, you want to know about the entropy method. Okay, so if let's say you want to do simultaneously for all this method, so you go to the automate. Okay, you go to the automate. Okay, you choose rows. Okay, you choose rows. Okay, so means that they provide the all the method inside this method: Gini, symmetry, entropy, class, probability, towing. Okay, so I go back to again here and then you choose type. Okay, so this one, they provide this one. So for example, you just want to proceed with the relative cost. So you need to find the last number of relative costs. So this one is ordering towing. Is have a smaller relative cost, but you want to know about that, so you just click, double click. So this one is the new tree with the method towing or order towing. Okay, but I think it's a similar thing. Okay, similar thing. Okay, so this one is the how automate works, and then this one is the features inside the SPM. For example, as we know, in the analysis engine, we have a card, we have a logistic regression, we have a marks, random forest. So you want to SPM run all the model for you. to your cases. Means that, let's say, give you some idea to starting do the modeling. So you can go for the automate again. Okay, automate again. You choose model. Okay, model. So means that this one, they run all the engine. Let's say car, mass, random forest, TreeNet, GPS, and so on. So you click start. Okay. So they generate the wait. Okay. So now So now they provide all the three. So let's say we go for the ROC. So you want to the highest ROC. So means that suggestion by the SPM. Okay, you need to using the TreeNet. So what is inside the TreeNet? So you just click, double click. So in the TreeNet. So in this TreeNet, you see that the ROC here is 0.999. So it's higher rather than um, cut. So go to the summary. You want to find the variables important. So also the same thing, production rate. But inside the TreeNet, basically they provide others features. Let's say they provide the display plot. Okay, I think I'm not sure that kind of features because it's more complicated, more to the technical side. Okay, but you can see that from the simple one. Okay, this one is a simple one. Just proceed with the 0.99967. But if let's say you go for the advanced one, you can get the higher accuracy 0.99968. Okay, so that's why that's why if you want to see the uh, impact or significant for the SPN side, you need to start with the cut and go to the advanced model. So let's say you go directly to TreeNet, you cannot see the beauty of this modeling. Okay. I think that's all. So I just review this uh, slide again. Okay. So from the card, okay, after you build a tree, so you need to see the ROC. Okay, for this case, because classification ROC. Okay, so from the ROC, you can go for the splitting side. Okay, and then you can go for the assessing. Maybe you want to proceed with the misclassification, or you want to proceed with the confusing matrices. After that, you want to know about the variables important. Okay, after that, you know about the variables important, you want to know about the parameter inside the variables important. Okay, so from the hotspot, okay, you can view this one. Okay, and then you can go for the SPN automation. Okay, so this one. Okay, so in summary, powerful machine learning tools such as cut, random forest, TreeNet, gradient boosting, and multivariate adaptive regression spline are useful additional to any practitioner toolkit. Okay, particularly when faced with the larger data set. The approach of the both side Minitab statistical software and the machine learning is a Salford Predictive Modeler play a critical role in finding actionable intelligence, and it will be the collaboration and communication between the two data-driven disciplines. Okay, so which is it will enable the organization to make a better decision and again a competitive edge. Okay, so I think we are running our time right now. I think if let's say you have any question, you just pop up under the panel question box. I think I will email you after this if let's say I don't have any time to do the question. Okay. Okay. Okay, so I think I go for the first question only. I think okay. What differences between regression model in mass SPM and the regression model in Minitab? Okay, as I mentioned, this one is the seems like regression, but not exactly same. Okay, the function is combination of linear. Okay, combination of regression linear for the Mars. That's why in the mask, they can capture the non-linearity and the missing data. I want to stress here, to be the good model for using SPM, basically you need to have a big data, and then basically you have a missing data value, you have a outliers value, so it's more beauty if let's say you want to using the cut model. Okay, because for this case, for the cut model is a non-parametric, means that doesn't have any assumption. For the regression, okay, for regression side, you have a lot of assumption. You need to fulfill the significant for all the variable. You try imagine if let's say you have a 10 variables, so you need to check one by one significant for one single main effect. If let's say you consider that 2 interaction, you have 20. If let's say you consider the 3 interaction, you have more than more. So you need to find one by one significant value. But for the cut, doesn't have any assumption. You can run whether your data is a missing data or non-linear data or outlier data. So cut can handle all the things. Okay. I think that's all for today webinar. If let's say you have some question, you can write in the panel. Okay, so if let's say you want to know the application for the Salford Predictive Modeler, you can go for our website www.minitab.com or www.business.com, or you can contact us for the sales@business.com, or you can minitab@business.com. Or let's say you want to get some tips or tricks on our product, Minitab product, follow us through media social like Facebook or link at the link Minitab Malaysia and Singapore. And then forget to subscribe our YouTube channel to access back our previous webinar. Thank you and stay safe.